Hi class, this video is for 5.2. We will start with example 2. The graph of a function f is given. Use the horizontal line test, okay? So horizontal line test to determine whether f is 1 to 1. So what I would like for you to go back to is go back and go over your horizontal line test definition, okay? Which is right here. Oops, I meant to use a highlighter. Which is right here. And on your own, yes, on your own, come back and do me a favor and answer both of this, okay? So tell me in these box right here, answers, whether they are 1 to 1 or not, okay? So once that's done, pause it for a little bit, guys, so that way you're not in a rush, okay? Pause it. And then once you're done answering those questions, then come and work this out together with me. Here we go. Example 3. Find the inverse of each 1 to 1. So they already told you that it's 1 to 1. Okay? So this is known. So you don't have to tell me that it's 1 to 1 or not. Now you just have to find the inverse. In addition, it wants you to state the domain and range of each inverse function. Okay? So let's try to do this one. Find the inverse. So first, inverse functions, you are just simply going to switch x's and y's, okay? So we're going to start with an f inverse is. This is giving you a set of order pairs. There are 1, 2, 3, 4, 5 order pairs. So we're gonna write 5 sets of parentheses. 1, 2, 3, 4, and 5, okay? And comma in between each set. So here we go. The inverse is, was just simply going to be switching x and y. X used to be -5, is now y. Y used to be 1, is now x. Is that simple? This one, they're both 3, 3, so even when you switch it, it's still 3, 3. This one is 0, 0, you're switching it, it's still 0, 0. This one is 2, -4, so it should be -4, 2. This one is 7, -8, so it's now -8, 7. See how easy that was? Okay. Then it went on and said, hey, find the domain and range, so of the inverse, okay? So I should give myself more space. But I don't have any, so we'll make the best of it, okay? So domain of f inverse, that's the notation for the inverse. The domain is a set of all x values, or your first input. So this is all the domains here, okay? So I'm just gonna write 1, 3, 0, -4, -8, and close that up. And I'm going to make this colorful. Range of the inverse with this notation. Again, it's a set of all the outputs, okay? So -5, 3, 0, 2, and 7. So -5, 3, 0, 2, and 7. And those are them. Not too bad, right? Let's move on to example 4. Example 4, verify that the functions are inverses of each other, okay? And it tells you how it wants you to find by showing that f composed with g of x equals x and g composed with f of x equals x. Then it says, hey, give any values of x that need to be excluded from the domain of f and the domain of g. That means, hey, do I need to exclude things that makes the denominator 0? Or do I need to exclude things that makes the radical negative? Okay, so that's what it meant by that. Well, you know what? What's interesting is this piece right here. This piece, okay? I'm gonna move this back up, so don't freak out. That piece, the composition equals to x. We did that already. Whoa, check this out. See this right here? This example is setting us up for proving that the two functions are inverses of each other, okay? So in 5.1, we did the basic work for the theorem. Okay, so now we are going to, so we did the math already, so you know how to do the math, and now we just have to use it to answer the question. Okay, showing that means I'm writing a proof, so let's do it. Here we go. Okay, so on that side, I need to show that f of g of x equals x. On this side, I need to do g of f of x also equals x. Okay, and if they are both going to come out to be x, then yes, g and f are inverses of each other. Okay, so let's check out g. G is a polynomial, so I don't need to exclude any values. F is also a polynomial, so I don't need to exclude any f is a third root, so I don't need to exclude any value either, because third root can have negative under the radical. So step 1, f of g of x is x to the third. Step 2, remember, show that, prove this. Okay, that means you're writing proofs, so make sure you're showing me all of your steps. Third root, okay, is your f function. Every time I see an x, I'm just going to put in x to the third. And look at that. Third root and x to the third, they are actually hint inverses of each other, so it comes out to be x, and that's what we want. Okay, let's see if this side's also going to do the same. Step 1, g of x, f of x is third root of x. Okay, and again, you may not do things in your head when you're showing proofs. Step 2, g is x to the third, so I'm just going to put in a blank and then to the third, and this gets a third root of x, okay? And again, third root and power 3, they also hint inverses of each other. So they both come out to be x. So you did the work, but make sure you answer the question, okay? It says here, verify that the functions are inverses of each other. So we did the work, which is this right here, okay? So make sure now we state that, yes, f and g are inverse functions, okay? And because they are inverse functions, because both of them came out to be x, okay? All right, let's do another one. So we're going to do exactly the same way, okay? Here we go. I'm going to break this up. Over here, we will compose f of g of x to see if it comes out to be x. Okay, that's our goal really. And over here, we will compose g of f of x to see if it comes out to be x. Okay. All right. What I'm going to do is I'm going to do this side. 1. F of g of x is 3 divided by x minus 5. Step number 2. I now have to write 3 over, I see an x, so that gets me to write 3 over x minus 5 plus 5, okay? Step number 3, we're going to try to simplify, so these two will cancel. So 3 over 3 divided by x. Step number 4, I'm going to write division this way, okay? Step number 5, I'm going to write 3 over 1 times x over 3, which that will allow me to reduce. So I will end up with an x, which is what we want, okay? Let's try this one out to see we will get the same. Here we go. G of f of x is 3 over x plus 5. Carefully make sure you're writing the 5. If it's on the bottom, make sure you show that the entire thing is on the bottom, okay? In step 2, we are now using the g function, so 3 over x plus 5. Take 5 over here, okay? So no, you don't, let me tell you what would be wrong is this. It would be wrong if you write minus 5 here, okay? So this is not okay. This 5 right here, it's on the side. So when, oops, I want to erase. So when you are writing that minus 5, make sure you understand that it goes like this, like 5 over 1, okay? So step number 3, I will do division first. So that's 3 divided by 3 over x plus 5. So division takes precedence of subtraction, okay? So I'm going to change this into a 1 because step number 6, I'm sorry, that's step 3. oops, I don't need the calendar. Step number 3 is that. Step number 4, I'm going to 3 over 1 times x plus 5 over 3. Do that first, and then subtract 5. Or 5 over 1 is okay too. Step number 5, I can reduce those. So now I have an x plus 5 minus, this is 5 and 5 over 1 over here. Step number 6, these two can cancel. I am going to end up with an x. Okay. So what is my statement? My statement is because they both came out to be x's, okay, therefore f and g are inverses or inverse functions, okay? Okay. Now, so we did all of that. We need to go back and state what we need to exclude from each function, okay? So when we did this, can you see this right here? Our initial input, okay? X can never ever be 0, because that would make my denominator 0. So make sure that's stated. And over here, when we did this initial input, this one, x can never ever be -5. Okay. So for us, don't forget to go back and state what those restriction has to be. All right. So that's how we do. That's how we determine, or that's how we can tell whether the two functions are inverses or not algebraically. So example 5 is now going to determine. Here we go. The graph of a 1-to-1 function is given. So it already know that this is a 1-to-1. Okay? You don't have to say that it's 1-to-1. It's already provided. Draw the inverse function, which is denoted with this f to the 1 power. So, well, an inverse function meaning that all of your points are going to switch. Okay? So switch x and y's, okay? So this point is -2, -1. So when I switch that, it's -1, -2, make a dot. And please label, okay? So this point is now this one. This point is -1, 0. So now I'm going to switch with 0, -1. Label the points, 0, -1. This point over here is 2, 1. So when I switch it is 1, 2. So 1, 2. Now that I have the 3 dots, I'm just going to connect them. And no, you don't go on forever because the original function does not go on forever. And we label this one f inverse. All right. What I would like for you to try now is try B on your own. Okay. So give yourself a couple of minutes and try B all on your own, please. Don't forget to label points. Okay. Now that you have done example B, let's try example 6. Example 6, find its inverse. Then, not only they find its inverse, you're graphing f and its inverse on the same coordinate plane on the right-hand side here that's provided. So to find an inverse, the first thing you will do is switch x and y's, okay? So here we go. This is y equals, so now it gets an x equals. This is x squared, so it's y squared. And we're going to add the 4. This is x is greater than or equal to 0. So now y is greater than or equal to 0. So look, you know the range, right? This is the range. Crazy, right? Range of an inverse. Okay. So now that you have switched, we are going to solve for y. Okay. So to solve for y, we will subtract 4 from both sides. So x minus 4 equals y squared. We will now take the square root to both sides. So when we take a square root, I'm just going to switch to y over here. Y equals, technically, we need to have a plus or minus of an x minus 4. But, I want to go and highlight this. It wants y can only be, this means y must be positive. okay? If y is positive, you may only keep the positive x minus 4. So writing a positive in front is kind of silly, so you don't have to, but that's what I'm trying to say, okay? So this is my inverse function, which we use this notation to denote that it's an inverse function, okay? So we found the inverse. Now let's graph it out on the same coordinate plane. So first we will graph this, okay? So let's graph that one with black, the original one with black, okay? So y equals x squared. I should say f of x, so let me erase. It's the same, but I'm just going to keep it consistent with the original. F of x equals x squared plus 4. You have a vertex at 0, 4, or you can make a table, okay? It only wants positive x starting at 0, so 0, 1, and 2. So here we go. So when x is 0, 0 squared is 0 plus 4 is 4. When x is 1, 1 squared plus 4 is going to be 5. 2, 2 squared is 4, 4 plus 8. So 0, go up 4. 1, 5, 2, 8. So this is your f of x, okay? Let's do in red, okay? Your f inverse is square root of x minus 4. And again, I'm just going to make a table. If you are not comfortable graphing that, you should be very comfortable with graphing that. So make sure you know how to by transformation, okay? This is just pretty much the eyebrow curve going to the right by 4. Okay, so I'm going to pick, I can't pick 0, okay, because that's going to give you a negative 4, and that's not going to be, we can't use that. So, and I can't pick 1, okay? So when I pick 1, what's happening? It's going to be a negative 3. Can't have that either. I can pick, so the smallest value I can pick is 4. So 4 minus 4 is 0. Good. Okay, the next nice number I'm going to pick is 5. 5 minus 4 is 1. Square root 1 is 1. Good. I need 3 points. Okay. So I'm going to pick 8 next. 8 minus 4 is 4. Square root of 4 is 2. So those are the 3 values we are going to use. So 4, 0, 5, 1, and 8, 2. Okay, connect these dots and label this F inverse. Wait, oh my gosh, aren't these the 4 values? Switching the x and y's? So technically, couldn't I just use this and switch? Sorry, forgot the C. So yes, you can use your original, switch the x and y point, and be okay to graph its inverse, okay? All right, y'all. This is the end of our video notes today. I will see you next time.